Okay, class, in this lesson, we are going to learn to create and use the graphs of a sine function. Um, this is a multi-part lesson, and so this particular lesson is going to focus on just the sine function. In the subsequent videos, I will talk about cosine function and other features of the sine and cosine function. Okay, so let's go ahead and get started with the sine function. So, what we need to understand is where the sine function comes from, and to better understand this, we have to take a look at the unit circle. Okay, so I'm going to focus in on the unit circle first, and as you will see, I've got some of these key features noted here. For example, I've got pi over 6, pi over 4, pi over 3, pi over 2, and I have similar items on in the second quadrant. Okay, and so one of the first things we want to do is identify the value of sine of pi over 6. So that's over here. Now, if you recall, the sine of pi over 6 is related to a 30, 60, 90 degree triangle. Okay, so let me kind of explain what I mean by that. So if I draw this 30, 60, 90 degree triangle, okay, and remember this point here is the origin, or the 0, comma 0 of the unit circle. Okay, so it's basically here. And what I'm doing is extracting, let me go ahead and draw this right here. I'm extracting that triangle, okay, and working it with it over here. Okay, and so what you should notice is that when we are at pi over 6, this is equivalent to 30 degrees. Now, if you forget how to convert radians to a degree measure, okay, you're just going to take the radian measure. So in this case, pi over 6, okay, and you're going to multiply that by 180 over pi. Okay, so when you go from radian to degree, you're going to multiply by 180 over pi. If you're going from degree to radian, then you're going to multiply by pi over 180, or the reciprocal of this fraction. Okay, and when you do, the pi's cancel out, and you get 180 over 6, which ends up becoming 30. Okay, so what this means is this angle right here is 30 degrees. Okay, which means this is going to be 60 degrees. And of course, this is a right angle, so that's 90 degrees. Okay, and remember, the sine of 30 degrees is the opposite over the hypotenuse. Okay, so let me go ahead and write that. Sine of 30 degrees is equal to the opposite over the hypotenuse. Okay, now the opposite side is 1 in a 30, 60, 90 degree triangle, but because the hypotenuse is equivalent to the radius in the unit circle, we know that to be 1. Okay, so if that is 1, then this length here has to be 1/2. All right, and so when we take the sine of 30 degrees, that's going to be 1/2. Let me go ahead and write this out. 1/2 over 1, which is equivalent to just 1/2. Okay, so in this chart, we're going to go ahead and complete the y values. Okay, and what you'll see is that the sine of pi over 6 is equivalent to 1/2. Okay, and then the sine of pi over 4 is square root of 2 over 2. And then the sine of pi over 3 is square root of 3 over 2. Okay, and then the sine of pi over 2, which is up here, is 1. Okay, and those are essentially the values you're going to need, and then all of the rest of the values over here are basically the same, but you just have to remember the sign, whether it's positive or negative. Okay, so in the first and second quadrant, all of my sine values are going to be positive, which means the sine of 2 pi over 3 is just going to be square root of 3 over 2. The sine of 3 pi over 4 is going to be square root of 2 over 2. The sine of 5 pi over 6 is going to be 1/2. And then the sine of pi is going to be 1. Okay? And now all of the values down here, they're all going to be negative, right? Because all of my y values in my third and fourth quadrant are going to be negative. So we can go ahead and continue. Sine of 7 pi over 6 is going to be negative 1/2. The sine of 5 pi over 4 is going to be negative square root of 2 over 2. The sine of 4 pi over 3, square root of 3 over 2. The sine of 3 pi over 2 is going to be negative 1. The sine of 5 pi over 3 is negative square root of 3 over 2. Forgot to negate this one here at 4 pi over 3. The sine of 7 pi over 4 is negative square root of 2 over 2. The sine of 11 pi over 6 is going to be negative 1/2. And then the sine of 2 pi, which is full rotation around the unit circle, will now be back to 1. Okay? All right, so if we were to take all of these values, okay, so you'll see that sine of pi over 6, my y value is 1/2, right? Halfway up the y axis. We can go ahead and graph that down here. So at pi over 6, that's roughly there on the Cartesian coordinate. And then if we were to take pi over 4 and duplicate that, that would put us right about there. And then if we were to take pi over 3, that puts us about right here. And then if we were to take pi over 2, that puts us about right there. And then if we were to take 2 pi over 3, that puts us about there. And then 3 pi over 4 puts us right about here. And 5 pi over 6 puts us about right there. Okay, so those are all positive values, and what we basically did was plotted these. Okay, and then we're going to repeat the same thing for the remaining quadrants, and these are all negative, so we're going to go ahead and put those in the negative position. All right, so that puts us right about there, and 3 pi over 4 puts us at about here, or I'm sorry, that's 5 pi over 4, and this is going to be the next piece here. All right, and then at negative 3 pi over 2, or I'm sorry, 3 pi over 2, not negative, that puts us there. And then at 5 pi over 3 puts us there. 7 pi over 4 puts us about here. And then 11 pi over 6 puts us about there. Okay? All right, so what you'll see here is essentially the sine curve. So let's go ahead and connect these. Okay, and you'll see that once it gets to 2 pi, okay, it will basically continue. And this is what we call the frequency. Or I'm sorry, the period. My apologies. Frequency is the inverse of the period. Okay, so the period of this graph, okay, so this graph is the function function is equal to sine of x, okay, this period is 2 pi. It's called 2 pi because it takes us to 2 pi on the x-axis, right? 2 pi before we complete another rotation, okay? So we would say that the period is 2 pi, and this is considered a periodic function because it is a function that has a period. It has its outputs repeat at a regular interval. Okay, in this case, it's 2 pi. Okay, so hopefully that made sense with a cosine function. I never really understood the origin of a sine curve. I was just told this is what a sine curve is. But now that we've learned the unit circle and how that relates to the sine curve, hopefully this makes more sense and helps you to understand where the sine curve comes from. Okay, hopefully that made sense. If you have any further questions or need to review this again, please go back to the beginning of the recording. Thank you.